The neuromuscular system also responds in different ways. This is because the nervous system will interact with the muscular system to control movement. These are controlled by the CNS and the PNS. The central nervous system is made up of the spinal cord and the brain. However, the peripheral nervous system, which is different, is made up of nerves that are connected to the brain and spinal cord. Control of movement. During activity, our body will recruit different motor units depending on different factors, such as duration and intensity. For a more powerful contraction, our body will use fast glycolytic muscle fibers, as when they contract, they will produce a large amount of force, but they can only be used for a short duration. If the duration is longer, the body is more likely to recruit fast oxidative muscle fibers, so they have a good supply of oxygen and can keep contracting for long periods of time, but they don't produce a large amount of power. We control our movement by detecting a stimulus by our senses. This is converted into an impulse by the brain. They are sent down a motor neuron to a muscle fiber. If the impulse is strong enough, it will cause a muscle to contract. Depending on how many muscle fibers are needed to contract, it will depend on the force that is provided. Motor units. We will detect a stimulus, which then is sent to the brain. Once it's there, it will send an impulse down a nerve. The axon is myelinated. The parts that are not covered by myelin are called the nodes of Ranvier. Because they are myelinated, this will speed up the transmission of the impulse by saltatory conduction. The action potential is also the jumping of the impulse. At a neuromuscular junction, ACH is passed over the synapse. It will come from the vesicle and presynaptic membrane and is spilled over to the postsynaptic membrane. This will then be in a muscle fiber where it will contract. Either all the muscle fibers in that motor unit contract or none of them do. In addition to that, they are also the same type of muscle fiber. A motor unit is made up of the nerve and the muscle fiber, which, as I just said, they are all the same type of muscle fiber. The nerve only controls the fibers that are in that individual unit. We have different types of proprioceptors in our muscles. We have muscle spindle apparatus and Golgi tendon organs. Muscle spindle apparatus measure the length or the velocity of muscles. This prevents us from overstretching them. Our response to this, when we detect a possible danger, is to make the antagonist muscle contract. Golgi tendon organs detect tension in the muscles. The amount of stretch is proportional to the tension in the muscles. Too much tension either makes the muscle contract or relax. This will then reduce the amount of tension in the muscles. Muscle spindle apparatus. Muscles are made up of extrafusal and intrafusal muscle fibers and gamma motor neurons. Extrafusal muscle fibers are the standard muscles that are involved in everyday contraction. They are on the outside and cover intrafusal muscle fibers and the gamma motor neurons. Intrafusal muscle fibers are a special type of fibers as they detect the length of the muscle. They are both afferent and efferent. Gamma motor neurons send that information of the length of the muscle to the central nervous system. This will then cause the muscles to contract or relax depending if there is any need to. Golgi tendons. Golgi tendons, which are in the tendons, for this example in the knee patella. They detect tension in the muscle when there is a slight contraction. For example, in the stretch reflex, when the tendon is hit in the patella, there is a sudden stretch in the muscle. For example, the quadriceps in this example. An impulse will then be sent to the spinal cord that tells the quadriceps to contract. However, at the same time, there will be an inhibitory impulse to the antagonist muscle, so the hamstring in this example. This is a protective stretch reflex. As it is a reflex, the impulse doesn't go to the brain, and they only go to the spinal cord. The motor neuron will cause the quadriceps to contract. When the stretch is too sudden or too much, and the muscles are put in danger, they will stop contracting, and the other one, for example in this instance, the hamstring, will relax. This will prevent overstretching and possible tears of the muscles, as it is a protective mechanism. For example, in the multi-stage fitness test, during the early stages we'll start off by using fast oxidative muscle fibers. This is as there is a low intensity and not much force is needed to be applied. As the intensity increases, different muscle fibers will be recruited. For example, during the medium and middle intensities of the fitness test, fast oxidative glycolytic muscle fibers are likely to be used, as there is a medium intensity and a medium duration. In the later stages, when the athlete is sprinting from end to end, they are more likely to use fast glycolytic muscle fibers, as they need a large amount of force to make it before the bleeps. However, during the Wingate test, as it is mainly power and high intensity for a short duration, the body is likely to recruit mainly fast oxidative glycolytic fibers, or fast glycolytic fibers. This is because you want to exert a maximum power for a short duration of time. As you can see in the Wingate test, we measured the amount of power recorded. As you can see, is 8.2 W/kg. The average power was also 6.5 W/kg. During this test, the body is likely to recruit a mix of fast oxidative glycolytic muscle fibers and fast glycolytic muscle fibers. This is because it is a very short test and you must use maximal power. Another sports application could be of the Golgi tendon during a bicep curl. Training can decrease the sensitivity of the Golgi tendon. This training will delay the protective and inhibitory response. This will allow an athlete to lift heavier weights. If the weight is too heavy and the Golgi tendons will then therefore detect too much tension, the protective response will then occur. This will happen by telling the bicep to relax and let go of the weight, as there is a danger of overstretching the muscle. The tricep will then also be told to slightly contract and allow the arm to extend down, and therefore it won't lengthen too quickly and it won't cause any damage by overstretching with too much tension.